All right, hello two P's. Welcome to the last lesson in this unit. And today we're going to learn about composite shapes. So our learning goal is to be able to calculate the surface area and volume of composite shapes using a variety of imperial and metric measurements. So, what in the world is a composite shape? Well, these are shapes that are composed of two or more 3D shapes. So, for example, we have our traffic cone here. It consists of a cone and a rectangular prism. These snowmen have more than a few spheres with them. The noses would probably be represented by cones. So you can see that in the other pictures that they're made up of two or more three-dimensional shapes. So we're going to just do a couple examples how to find surface area and volume of these 3D composite shapes. So let's take a look at this shed. It has all its measurements on it, and what you need to do when you're looking at a composite shape is break it down into the different shapes you can see. So this shed is made out of the bottom here is a rectangular prism, and then on top is a triangular prism. So to find the volume, you're going to find the volume of both of these shapes. So we're going to find the volume of the rectangular prism, which is just the width times length times height. So that's 20 times 35 times 10 gives us 7,000 centimeters cubed. And then the volume of the triangular prism, well, if you remember, it's half of the rectangular prism because they have the same height and the same base and the same width. So you can think of this one as half of width times length times height, which is 3,500 centimeters cubed. So our total volume for this shape is 10,500 centimeters cubed. Okay, now surface area, um, the volume always seems to be an easier calculation, doesn't it? For surface area, we need to make sure we can get each of these surfaces that is on the outside and make sure that they are included. So if we start with this front face of the rectangle, that's 20 times 35, but there's also one on the back. So we need two of those, so that's what the first one is. And then this side here is 10 times 20, but there's also one on that side as well. So I need two of those. 35 times 10 is the bottom of this shed, so we're going to include that. We don't need to include the top of the rectangle though, because we can't see it. It's not exposed to the air, if you will. Okay, so those are all the rectangular prism sides. Let's look at the sides on the triangular prism. Well, we've got this side here, which is 29 by 10, and there's only one of them because this one's over here has a slightly different dimension. So this one is 23, the length here, but the width is also 10. Okay, so that takes care of those two sides. And now we need this front part and then its corresponding back part. So remember, to find surface area of a triangle, it's 1/2 base times height. Our base here is 35 and our height is 20. But because there's two of them, I'm going to go 2 times 1/2 times 35 times 20. And we're going to add all of these numbers together. So if I multiply all those through, these are the numbers that we get by multiplying all of these. And now I'm going to add all of them up to get my total surface area, which is 3,370 centimeters squared. Remember, we use cube for volume and squared for surface area. Okay, let's do another one. Example 2, let's see, we have this silo here. Let's take a look at what two shapes are here. Well, on the bottom here, that's a cylinder. And then on the top, we have half a sphere. So that's called a hemisphere. So that's half a sphere. So let's take a look at the volume first. So we're going to find the volume of the cylinder and then volume of half a sphere. So volume of a cylinder is pi r squared times h. So 3.14 is pi. R is the radius. Remember, this is the diameter here. So the radius will be 5. And then the height is 6. So if we multiply those together, remember 5 is squared. So that's 3.14 times 25 times 6 gets us 471. The volume of the hemisphere is half of the volume of a sphere. So remember, the volume of a sphere is given by 4/3 pi r cubed. So half is 0.5, 4/3 is 1.3, pi is 3.14, and then we put 5 in for r, and that's r cubed. So that becomes 125. So if we multiply all those numbers, you get 255.1 meters cubed. So that means our total volume is, adding these two together, is 726.1 meters cubed. Okay. Let's take a look at surface area then. Well, if we look at this, for the cylinder, we definitely have a cylinder. We have the bottom of the cylinder, but we don't have the top, okay, because the hemisphere is covering it up. So you're going to do the side and one of the ends, but not the top. And then we only have half a sphere, so we're going to have to multiply surface area of a sphere by half. Okay, so for the bottom of the cylinder, it's pi r squared is the surface area. For the side, it's 2 pi r times h. And then for the hemisphere, it's half times 4 pi r squared. Now we're going to put in all the numbers that we know. So every time we see a pi, I'm going to use 3.14. Every time I see an r, I'm going to use 5. And every time I use h, I'm going to have a 6. So here are all the numbers put together, and now we're going to multiply those out. So this becomes 78.5, these become 188.4, and these become 157. I do highly recommend you try calculating these out to make sure you're getting the right numbers, or at least close to what I am. Remember, if you have a pi button, these will be slightly different, but close. Okay, so once we add all those up, we get 423.9 centimeters squared. So that is the surface area of the silo. So those are the examples I'm going to do with this. So for you to try, there are 2 practice sheets posted on Brightspace. One is volume and one is surface area. Once you feel comfortable with that, you can go ahead and try 5.7 quiz, and that will be your last quiz. All right, that's it for this lesson. Stay tuned for review next week.